Okay, so now in this section, in this lecture, we are going to see some derivations like velocity distribution for turbulent flow in terms of average velocity. Okay, so we are going to derive the previous expressions in terms of average velocity for turbulent flow. Velocity distribution for turbulent flow in terms of average velocity. So consider a circular pipe and consider an elemental ring within it of thickness dr. So if you project it in front view, you can see the ring thickness dr and the radius of the ring is small r and radius of the pipe is capital R. Flow is happening, turbulent flow is happening from left to right. Okay, so now usually Q is given by area into average velocity across the cross section of the pipe, that is area into pi r square into u bar. Okay, so for elemental circular ring your dq is given by discharge through the elemental ring of thickness dr is given by area, cross section area of ring into velocity. It is given by 2 pi r, that is the circumference of the ring into thickness of the ring into u. So it is u 2 pi r dr, dq is equal to, therefore total discharge q is equal to integration of dq is equal to integration of u into 2 pi r dr. Okay, now further, in case of smooth pipes, the velocity distribution is given as u upon u star is equal to 5.75 log to the base 10 u star into y upon nu plus 5.5. Therefore you can write u is equal to 5.75 log to the base 10 u star into y upon nu plus 5.5 into bracket u star. Now substitute this, mark this as equation 1, put the value of u in equation 1. Therefore q is equal to integration of dq is equal to integration of 5.75 log to the base 10 u star y upon nu plus 5.5 into u star into 2 pi r into dr. Now as average velocity is equal to u bar is equal to q upon area, that is q upon pi r square for pipe, for circular pipe. So we can write u bar is equal to 1 upon pi r square into integration from 0 to r 5.75 log to the base 10 u star into y upon nu plus 5.5 into u star into 2 pi r dr. Now y is equal to capital R minus small r, which is given as this distance y. Okay. Therefore your average velocity becomes equal to 1 upon pi r square. Inside integration we have 5.75 log to the base 10 u star into capital R minus small r upon nu plus 5.5 into u star into 2 pi r dr. Now further simplification and integration of the expression will give you the final expression as u bar upon u star is equal to 5.75 log to the base 10 u star into capital R upon nu plus 1.75. So this is the expression for average velocity distribution in terms of average velocity for smooth pipes. Next, for rough pipes, we have velocity given as u upon u star is equal to 5.75 log to the base 10 into y upon k plus 8.5. This is already derived. Now we have to convert this equation in terms of average velocity. Y is equal to r minus r. Therefore u upon u star is equal to 5.75 log to the base 10 r minus capital R minus small r upon k plus 8.5. Average velocity u bar is equal to q upon pi r square. Therefore u bar is equal to this equation u upon u star is equal to 5.75 log to the base 10 r minus r upon k plus 8.5 into u star. Therefore q is equal to integration of 5.75 log to the base 10 capital R minus small r upon k plus 8.5 into u star into 2 pi r dr. This is your q. Therefore your u bar, that is average velocity, is equal to q upon pi r square, that is equal to 5.75 log to the base 10 into r minus r upon k plus 8.5 into u star into 2 pi r dr upon pi r square. Further integration and simplification will give you an equation, that is u bar upon u star is equal to 5.75 log to the base 10 r upon k plus 4.75. So this is the velocity distribution for rough pipes in turbulent flow in terms of average velocity. Okay. Now after this derivation, let us see some another expressions like difference of the velocity at any point and average velocity for smooth and rough pipes. So they have asked you to find out the difference between the local velocity and average velocity for smooth and rough pipes. So for smooth pipes, for turbulent flow, we have equation u upon u star 5 is equal to 5.75 log to the base 10 r upon k plus 4.75, as we have the equation is u upon u star is equal to 5.75 log to the base 10 u star into r minus small r upon u plus 5.5. Okay, and this is local velocity. Average velocity is equal to u bar upon u star is equal to 5.75 log to the base 10 u star into r upon u plus 1.75. Difference of velocity u and u bar for smooth pipe is u upon u star minus u bar upon u star is equal to 5.75 log to the base 10 u star into r minus small r upon u plus 5.5 minus 5.75 log to the base 10 u star into r upon u plus 1.75. Therefore u minus u bar upon u star is equal to 5.75 into log to the base 10 into u star into r minus r upon u minus log to the base 10 u star into r upon u plus 5.5 minus 1.75. Therefore u minus u bar upon u star is equal to 5.75 log to the base 10 and u star into r minus r upon u minus u star into capital R upon u plus 3.75. Therefore u minus u bar upon u star is equal to 5.75 log to the base 10 r minus r upon nu plus 3.75, which is equal to 5.75 log to the base 10 y upon nu plus 3.75, as y is equal to capital R minus small r. So that is the expression for the difference between local velocity and average velocity for smooth pipes. Similarly, for rough pipes, your local velocity is given as u upon u star is equal to 5.75 log to the base 10 into y upon k plus 8.5. And average velocity is given by u bar upon u star is equal to 5.75 log to the base 10 upon r upon into r upon k plus 4.75. Difference u upon u star minus u bar upon u star is equal to 5.75 log to the base 10 upon y minus y upon k plus 8.5 minus 5.75 log to the base 10 r upon k plus 4.75. So u minus u bar upon u star is equal to 5.75 into log to the base 10 y upon k minus log to the base 10 r upon k plus 8.75 plus 4.75. Therefore u minus u bar upon u star is equal to 5.75 log to the base 10 y upon r. Plus 8.75 13. So this becomes 9, so this becomes 3.75. Therefore u minus u bar upon u star is equal to 5.75 log to the base 10 y upon r plus 3.75. Here this becomes r, so this is r.